On this part, number 4, we will discuss about specific of the combustion, about the different type of fuels and contaminants that may exist, and also emissions from gas turbines. The first thing we're going to see is the combustion system, and after that we'll see different types of combustors that are often used. And once we have covered the specifics of the combustion, we will get into the emissions, which is a very important topic nowadays because of environmental concerns. And after looking at the emissions related with this topic, we'll see different types of fuel that may be used on gas turbines and the problems that they may have. And the last part will be devoted to contaminants, because it is essential that we eliminate all the contaminants if we want to have a reliable operation. The first thing we need to discuss is what is the function of the combustion system. In reality, the function is threefold. Well, the first one and obvious is mixing the high pressure air from the compressor discharge with the fuel, and also burning this mix to produce hot and high pressure gases, which will be expanded in the turbine to obtain useful power. And not less important is controlling the flame temperature, because this has a lot to do with emissions, as we will see later. And not only for the emissions, but also because the very high temperatures or the spots with very high temperature inside of the combustor, they usually reach temperatures that are well above the maximum limit that the metallic material will withstand. So you have to make sure that these high temperature spots, they don't come close to the metal walls. When we are talking about the elements of the combustion system, we have the fuel injection nozzles that are also known as burners, the igniters, and the combustion chamber itself, or chambers, because it may be more than one. Getting into more detail in how a combustor system all these components are put together. Just to go in sequence, the compressed air that is coming from the compressor is mixed with the fuel, and this is done by the burners. And the burners are attached to a chamber that is called a combustor. And this mixture of fuel and air is ignited by the spark plugs or igniters, and this happens very close to the exit tip of the burner. In fact, if this is excessively close, you may have damage to the burners. And the function of the combustor, as we said, is to produce a uniform flame temperature distribution and also keep the high temperature away from the metal. One thing that is important to mention, because even in these modules we'll discuss a lot about flame temperature, but flame temperature is not realistic, it's difficult to measure, and also is not useful. What we are really concerned is the turbine inlet temperature, because the temperature of the gases that enter the turbine is what gives you an idea of the energy that is in this hot gas. So this is the temperature that we mean. Even when you hear talking about flame temperature, most of the time people mean turbine inlet temperature. And to give you an idea, we are in areas close to 1350 degrees Celsius. This is where technology more or less is moving now. Now that we have discussed what the combustor is, let's see the different types that we may find in gas turbines nowadays. There are three types of combustors. The first is the can combustor. In this case, we have an individual burner cans that are mounted around the periphery of the engine, and the example shown in this picture is from a Siemens SGT200. This is a turbine that formerly was known as a Tornado from Alstom. The second type is the annular combustor, and the model shown corresponds to a GLM 2500, and this is typical of aeroderivative gas turbines. And the last type is a can annular, which is a hybrid type in between the two. And the model here shown corresponds to a GE frame 5. This is typical of heavy-duty gas turbines. Well, Can combustor is also known as a silo combustor or side combustor because it's just one combustor putting on the side of the turbine. The individual burner cans, they are mounted around the periphery of the engine. Each can is an individual combustion chamber with its own fuel supply. And single-stage side combustors were used on the early European designs, and we've already mentioned this. The advantages of this type of combustors is that replacement is very easy because it's not integrated as much in the turbine. But there are a number of disadvantages, and this is why they are becoming less popular. They are inefficient and they are structurally weaker than other types because they are less integrated. So the ease of replacement has this disadvantage. And also very important, they have a tendency to distort the casing with high firing temperature. As the firing temperatures they have been increasing with the years in order to increase efficiency, this is one of the reasons that can combustors are less and less popular. Here you can see an installation of the can combustor, and this is installed on a GE10 turbine. You see that the can, this is what would be a typical can, and here you see the installation of the can inside of the casing. The annular combustor. In this case, you have one large combustor within the engine core. And then on this annular combustor, you have multiple fuel nozzles that they form a single ring of fire. And it is used on all aeroderivative gas turbines. And the main reason is that it allows to reduce the frontal area, thus improving aerodynamics, which is very important, obviously, on an aircraft. The advantages are that they are very efficient and they are very strong because they are integrated in the core of the engine. And as we mentioned, the frontal area of the turbine is reduced, and this is much more important on aircraft engines than on industrial uses. Disadvantages is that repair or replacement requires complete engine disassembly, and this has a lot to do with the way maintenance is done on these turbines. Here we can see an example of the installation of an annular combustor. On here on top, this red area is where the combustion takes place. If you look at the top and the bottom, the reason they look different is that this is what is called a single annular combustor, and this is a dry low emissions combustion system. So it's not that on the same turbine you have both. You have either this type or this type. It's just for the matter of for sake of clarity, we wanted to show these two types of annular combustors in a single shot. The third type is the can annular combustor. As its name implies, it's a hybrid between the two other types. And on this one, there are a number of individual cans with separate fuel nozzles that they receive air from a common annular housing or manifold. And they are used on all heavy-duty gas turbines and most of the industrial gas turbines. And the can combustor we mentioned before, that was pretty common in European designs. On the contrary, can annular was typical on USA industrial turbine designs. And because we have multiple can annular combustors, they are connected by crossover tubes to help propagate flame and equalize pressures. And there is no need for scaling as other components. You can use, if you're making a smaller gas turbine, you can use less combustors, identical design. If you are going to a larger gas turbine, just put more of these combustors. So this is a good advantage of this type of combustor. The advantages of can annular combustors are significant, and this is the reason they are becoming more and more popular. Well, they are strong, and replacing them is quite easy. Lab tests are done in a single full-size combustion chamber. The actual operating conditions are tested, so the combustion dynamics, heat transmission, emissions, can be reproduced exactly, which is very convenient to avoid surprises when you are going to full scale or to production. Less fuel is needed for testing because of the same reason. I mean, you are using only one of a number of combustors. They are easy to adapt to a larger variety of fuels by changing the length and or its diameter, and this is the reason that heavy-duty gas turbines are much more flexible in terms of fuel types that may be used. They have also smaller dimensions of component parts. That means easier cooling, reduced thermal and mechanical stresses, and also ease of maintenance because the weight of the parts that we have to deal with are smaller. And the same combustor is used for different gas turbine sizes. This component, as we said before, is not scale. You only have to use as many combustors as you need for the larger or the smaller gas turbine you want to build. This reduces the product development cost and also the duration, and avoids risk associated with new designs, reduce inventory of spare parts, and also allows to accumulate operating data faster. Talking about the disadvantages, because everything has also a disadvantage, they are less efficient than annular